All right, so looking at our schedule today, whew, we are chugging along. It is day 21 of our 60-day adventure. We are in the middle of the week on Wednesday, January 6th. We're going to, again, Unit 2, Project Workday. So you'll be working on your project. We are your resources. If you have any questions or have any concerns or anything like that, we're here for you. Tomorrow is when it's due. So there is no live classes for science. Obviously, there's others for your other classes, but there is no live classes for science. So please make sure that you are looking at this and that you are getting your stuff in. If you've been with us and participating all through this time, this should be pretty easy. You should be able to turn it in and be done with it. Easy peasy lemon squeezy. Friday, we're going to be starting our Unit 3, so get ready for chemical formulas, and we will talk about that on Friday. So again, work day today, due tomorrow.
All right, let's go ahead and open up our projects. Today is a work day, so it's a day that we are going to be a little bit more strict about participation. So if we check in with you several times and you do not respond, we will log you out because that tells us that you are non-responsive. That tells us that you are not at your computer. Most days we are not that strict, but today we are being very strict about it because it is a work day and we are responsible to people who are above us that are checking in with us and how we're working with students. So that means that you do need to be participating and showing that you are working throughout class. So in order for us to be responsible to those people, we need you to be responsible to us and to be responding to us and to be participating. So again, if after several attempts you don't respond, we will go ahead and log you out. So just as a heads up. No bueno, exactly. Hi, Omar, how are you doing? All right, so here we go. I'm going to go ahead and take a look here. So you need to go ahead and open up your project and raise your hand. So if you already started it in Google, here is the folder for you to find that Google project. If you started it in PowerPoint, just open it up on your computer because PowerPoint is on your computer. If you have not yet started, then let's get it started, all right? We can't do anything about what's happened in the past, so we're not going to be upset that you haven't started it yet. We're going to be upset if you have an opportunity right now to start it and you still don't start it, okay? So let's just look to the future. Let's be positive about that. It's better for you to do something now than to continue doing nothing, okay? So let's do something now. Yes, okay. Okay, no worries, Shelby. All right, so well, you'll get some time to do some good Google research then today. So here is Mrs. Larkin's grade tab, my grades tab. Here is Mrs. Sepulveda's grades tab. So in there you will see there's a Google version that you can click and make a copy if you have a Google account. If you don't, you can always make one. Just look up on Google how to make a Google account. And then if you have PowerPoint on your computer, click the PowerPoint version and you can download that. So use one or the other, whichever one works for you, and raise your hand. While we are doing that, and again, I do expect 100% participation, but while we are waiting for 100% participation, I'm going to go ahead and show you up here really fast how to look at your grades tab. So no excuses because you can look at, I'm showing you exactly right now what your grades tab looks like. Yeah, absolutely, Shelby. No worries. As long as it's all on your slide and it's visible to the naked eye, that's fine. All right, let me share this with you up on the whiteboard. Cool. All right, so here we go. This is your class right here. Obviously, this is Mrs. Larkin's. If you're in Mrs. Sepulveda's, though, it's still the same instructions. It looks identical. So up here, you're going to go ahead and click the grades tab. And again, we also sent the direct links in the chat box. No excuses. And when you scroll down, you will see right here, this is the Unit 1 project. But today we are working on the Unit 2 project, okay? So here's the Unit 2 project, and here are all the recordings that go over every slide in that project. I want to point out specifically to you that the project slides we have not yet covered. I did upload that recording, so that is there for you right now. So most of you will probably be focusing on that if you have been staying caught up during classes. If you haven't, then obviously work on whatever you need to work on, but you do need to work on a slide in your Unit 2 project today during class, okay? So again, though, this last link right here for the instructions, most of you will need to be looking at that one today. Smiley faces, emojis, if you understand. Smiley faces, emojis, if you understand. Everything is in your grades tab. There are never any excuses. We update the grades tab religiously, all right? So please make sure you're looking at it all the time. Also, if you do finish during this class time, you can sit tight once you finish. But if we come and check in with you and we ask you what you're doing and you're like, I finished, then I should see a finished submission in the submission folder, which is right here. And you should, it should be a good submission. If I look at it and it's blank, or if I look at it and you clearly were making up answers, I'm going to tell you to go back and try again. Okay. Taking a look here, these same links to open up your projects are here. There's the Google folder. Again, if you downloaded PowerPoint, open it on your computer. If you have not yet opened a template, those templates are right here for you. So again, no excuses. Everything is in your grades tab. I sound like a broken record, but I cannot emphasize it enough. No student should come to me at the end of the trimester and be like, I can't find anything. It's in your grades tab. Okay. So I'm done sharing that. Let me jump back into our PowerPoint here. Sorry, into our PowerPoint. Okay, so again, I do need raised hands from everyone. This is your first chance to check in with us and let us know that you are here. So I'm going to give you another few seconds and I'm going to call out some names that we don't see raised hands yet. Again, if you can't figure out how to raise your hand, just talk to me in the chat box. That's an easy way to make sure that I know you're here. Okay, waiting on Monique, Christopher, Timothy, Tayan, Kamari, Adriana, and Julia in the chat, and Jaden. Thank you, Miles. Thank you, Adriana. Thank you, Timothy. Okay, still waiting on Monique, Tayan, Kamari, Gabriel, and Julia. Julia, if you are in the chat, let me know. Sorry, I saw someone raise their hand, but they didn't keep it raised, so I don't know who that was. Again, Monique, Tayan, thank you, Gabriel. Monique, Tayan, Kamari, thank you, Julia. Monique, Tayan, Kamari, you're my last three. Thank you, Tayan, thank you, Kamari. Monique, you're my last person. Come on, let's do 100%. Monique, you're my last person. Are you there? Hello, hello. Raise your hand if you have your project open. Oh, so sad. We were so close. Okay, we're going to move on, Monique, but we will be checking in with you again. Again, we're going to be very strict about participation today. So if we try checking in with you throughout the entire class and you don't respond, then you will be logged out before we get the attendance at the end of class. Okay, thank you. All right, let's go ahead and move on here. So some project information and some of this is really advantageous to you. So let's take a look at this. Projects will be graded over the weekend. So you have a bit of a grace period, okay? So we won't zero them out until the weekend. So you have a bit of a grace period before those zeros are in your grade. But obviously, even after we zero it out, you can still turn it in and replace that zero with a better grade, assuming you do the project correctly. But we obviously don't want those zeros in there for very long because our parents don't like that. We don't like it. It doesn't make us feel good. So let's just get it in. That way we don't have to see those zeros. I would also mention that the projects are worth 85% of your grade. So if you're missing projects, then your grade is not going to be passing. Okay, so for example, right now, the only project in our gradebook is the Unit 1 project, which is worth the entire 85%. So if you're not passing right now, it's because you haven't done the Unit 1 project correctly. The highest grade you could possibly have without doing the project is a 15%. It's impossible to pass. It's literally the only real assignment we do in our class are the projects. So if you're not doing those assignments, then that means you're not doing any real work in our class, which means you do not earn the right to get a passing grade. I know that's very kind of stark in the way I'm saying it, but I want to be straightforward so there are no misunderstandings, okay? Do your projects, do your projects. Okay, that being said, there is an advantage to the way that we also grade our projects, okay? So let's focus on this. We haven't really mentioned this very much, but just so you know, Mrs. Sepulveda and I actually grade your projects on a 50% to a 100% scale, which means that as long as you provide a valid attempt, meaning there are no blanks, and meaning that it's clear that you watched the recording while trying this attempt, then the lowest grade you can get on that slide is a 50%. Okay, so that's amazing because that means that even if you do poorly on one slide, it's not going to hurt your project very much, right? So this is to your advantage. Just means that you can actually get a great grade on your project, even if there are some things that you don't do well, because we're not going to punish you for doing well. We're going to encourage you we're not going to punish you for a few mistakes. We're going to encourage you for everything that you do well. Smiley faces, emojis, if you understand. I know it's a huge relief. Okay, yeah, we should really sound this out more often, but this is really a huge advantage to you. Yeah. Yeah, I know sometimes it feels like, oh, I turned in my project. I don't feel like I did that great. But as long as you tried, most students get really good grades and you're often surprised at how good you do. So that's just more encouragement. You just need to try. Okay. It's to your advantage to just try. It's to your advantage to make sure you don't leave anything blank. So that's what we mean by trying. Don't leave anything blank. And especially make sure you're doing it while watching the recordings, because here are some examples of things that you might have filled out but don't count as a valid attempt. For example, if the question is shown in the recording that it explicitly, specifically was meant to be a single answer question, and you just check off everything in it, or you check off multiple answers, that's clearly nonsense. That is, you are clearly guessing and putting a nonsense answer in. That does not count as a valid attempt. That's an automatic 0. So just give me a valid attempt, follow the directions in the recording, and that way the lowest grade you could possibly get, that cutoff mark, is a 50% instead of a 0. Yeah, exactly, Shelby. So there's always a learning curve, but again, that's why it's really important for you to be watching and following along with the recordings. Another example, if we explicitly, specifically give you a number or a fact in the recording and tell you this is the answer to this question, but you put in something random, like a random number or a random answer, then one more time, that is not a valid attempt. Okay, it is very obvious that you have not watched the recording when you have random, nonsensical answers. So please watch the recordings, try every single one in the PowerPoint. That way, the lowest grade you could possibly get is a 50%. Honestly, this means as long as you get one thing correct on every slide, you will pass the project. So your goal should consistently be to try on every single slide, okay? I'm gonna send out the attendance one more time, and then we are going to erase that in 30 seconds. So just a reminder, get your start of class attendance in. It starts with the letter N. Otherwise, if you miss it now, you will only get partial credit. Okay, so get that now. I'm gonna start a timer for 30 seconds to make sure I give you enough time to finish that up. Okay, beautiful. So do your projects, watch the recordings while doing them, and don't leave anything blank. That's the summary here, and that will ensure that you do well in our class. Okay, now here's what we're... Hello students, at this point we have already completed previous project slides 1 through 4 and 10 and 17 and 22. So make sure that you refer to the recording that went over those project slides. Today we're going to go ahead and take a look at the remaining project slides, as well as you've already completed all the notes. So at this point we only have slides 28, 29, 33, 37, and 38, 38 of which is extremely easy, as well as, slide 29, and 33 is pretty easy as well. So let's go ahead and start off with the hardest one. This is going to be slide 28. So it's going to ask how many total electrons, and not just valence electrons, does an atom of your element have if it is neutrally charged? Recall that in a neutrally charged atom, protons equals the electrons, and we know that protons come from the periodic table. So I'm going to go ahead and just type that up here. So protons come from the protons slash the electrons to make it neutral, come from the atomic number in the periodic table, which I'm going to go to ptable.com to do that, and so should you. Okay, so this is a reminder that I am using carbon as my example, just like I did in the previous video. So carbon is my example. Do not copy. You weren't even allowed to choose carbon as your example, as your element. So obviously if you choose carbon, you automatically get a 0 on all of your project slides. Okay, so recall in a neutrally charged atom, protons equals electrons. So we need to figure out what's the atomic number. That'll tell us the protons, and that'll tell us the electrons in a neutrally charged atom, again, because equal amounts of positives and negatives will cancel out to neutral or 0. So I'm going to go ahead and jump over to ptable.com. All right, so ptable.com, here I am right here, and taking a look here is carbon. So I'll go ahead and click on that right there. And taking a look at some information about carbon, remember that our atomic number, so our AN atomic number, is going to be this number up here, which is going to be equal to the number of protons. Sorry, I'll make this smaller again because I don't need it that large. All right, so this is going to be equal to our number of protons, and electrons if neutrally charged. Okay, so currently that's the number 6. So easy peasy, I'm going to jump back over here and I'm going to put 6 for mine. Again, please do not copy because this is just my example. So 6 total electrons in a neutral atom for carbon. Excellent. So how many total electrons? Again, total electrons doesn't mean just valence electrons. Again, you saw valence electrons in your Bohr model slide, but we're actually talking about total electrons. So how many total electrons does a stable ion of your element have? We're going to refer to the project All About My Element slide because we need to figure out, is it going to gain electrons or lose electrons? If it gains electrons, we need to add those electrons to this total up here. And if it loses electrons, we need to subtract from this total up here. So let's go ahead and take a look at my project All About My Elements slide. I apologize. This is actually the project My Elements group slide. So let me go ahead and correct that. So this right here is actually the project My Elements group slide. Okay, so that's going to be up here at slide number 17. So taking a look at slide 17, we decided here how many does our atom lose or gain. Again, that's something that you already should have done from the previous recording, so you should have deleted whichever one of these is wrong, right? So if it loses, delete the word gain. So lose 2, gain 4, gain 3, whatever. So in this case, carbon's kind of unique. Remember, we talked about how carbon actually shares electrons, but for the purpose of this, let's just pretend that we are saying that carbon, so pretend that carbon gains 4. Okay, so again, that's not actually true because carbon actually shares electrons, but we'll pretend that carbon gains 4. And again, that's why I'm using this as an example. This is not one of the ones that you should have used because obviously it doesn't really work as well. So we're going to pretend that carbon gains 4. So if that is true, then if we start off with 6 total electrons and we're gaining 4, then we need to add 4. So right here, I'm going to go ahead and add 4 to this number up here. Okay, and 6 plus 4 would go ahead and give me 10 total electrons. So 10 total electrons here. If we decided that it lost 4, so for example, if we said that, let's pretend that carbon loses 4, all right, so in that case, we would actually subtract 4. All right, so let me go ahead and delete this right here. So we would actually subtract 4, in which case 6 minus 4 would give me 2 total electrons in a stable ion. And again, stable meaning that it is happy, right? That's the purpose of gaining and losing electrons, is to be happy, to be stable. Okay, so whichever one of those yours does, make sure that you do that. So I'm going to still pretend that mine actually adds 4 just for the sake of this. So I'm going to go ahead and go here. And let's go ahead and delete this and make this again 10 total electrons. So that being said, we're going to go ahead and then take a look at the final charge. So calculate the charge of a stable ion of your element. And so what we're going to do, this is something that we learned in one of the video recordings from when I was out sick, so make sure you go back to the video recordings. But we're going to take the proton charge and add it to the electron charge, and the electron charge is negative. So you can see that right here, it is a negative charge because electrons are negatively charged. So protons are going to be from our atomic number, which we already learned our atomic number is 6. So it's actually the same as this number right here. So I'm going to go ahead and just kind of pop that number in right here. Again, so 6 positive protons. Okay, again, I know it says 6 total electrons, but it's neutral, so it's going to be the same number of positive protons. And then the electron charge of the stable ion, which that electron charge is right here, and that's going to be 10, and I'm going to make it negative, so negative 10. All right, so I'm going to go ahead and grab my calculator really quick. So let me grab my calculator. Here we go. And what we're going to go ahead and do is we're going to go ahead and do, let's see here, this 6 plus negative 10. So 6 plus 10, but make that 10 negative with this sign right here, and that'll give me negative 4, which makes sense. I have more negatives than positives, so 6 minus 10. Again, another way to think about this is saying 6 minus 10, right? So if we're subtracting a bigger number than what we start off with, we end up in the negative. So my answer here would be negative 4. If, for example, this was again 2, because I said that if we pretend that we lose 4 electrons. So if in this case in a stable ion this was 2, then taking a look at that example, I could change this to A2. Again, this is only if you are somebody that loses electrons. Then 6 plus negative 2, again, is the same as saying 6 minus 2, right? So we could do it either way. So I could say 6 plus 2, but make that 2 negative, and I get a positive 4. Or I could say 6 minus 2, and that would give me 4. Again, you can also do, from our previous example, 6 minus 10, and that would give me negative 4. All right, so that's another example of if you, in fact, actually gain you lose electrons. So in this case, this would be a positive 4. Okay, in my stable ion, my happy ion, the one that has lost and gained the amount of electrons that it wanted to lose or gain. All right, so that's how we do that. For slide 29, you need to go ahead and get a real photo of your element. So this one you can just Google. All right, remember to put in a photo. You can go to insert image and upload from a computer if you have it saved to your computer. You can also just copy it from Google. So if we go to Google Images and we're going to go ahead and search for carbon, picture of carbon. Right, so here we go. These are all pictures of carbon. Diamond is pure carbon, so I could copy this, right click, and go back over to my slides, right click and paste. All right, so you can drop that in there as well. Again, that is only if you are, this is, don't copy carbon again, because carbon is my example. Carbon is not one of the atoms you are allowed to do. Slide number 33, we talked about this in class. What are 3 important uses of your element in real life, and explain? So you need to look it up. It's used in blank, which is blank. It's used in blank, which is blank. It's used in blank, which is blank. So for this one, it's really easy. Just look up carbon uses, or for your elements, obviously. And then there's a ton of articles that tells you what all of your things are used for. Now be specific. So for example, don't just say jewelry for carbon. So for example, I would say right here, like jewelry, carbon example, don't copy. Okay, so if I'm taking a look at this one right here, don't just say jewelry. You need to be more specific. So then I would explain more, right? Which is diamonds are made of pure carbon in a solid structure, in a crystal structure. All right, and then same thing down here, right? If we're talking about medicine, don't just say medicine, say it's used in medicine, which is when, right, your thing, like tell me the type of medicine or tell me what procedures it used for. You don't have to be super expansive. If the text goes off the page, make it smaller. Remember, you can go ahead and just highlight this and then make it smaller up here, decrease font size, because if it goes off the page, we can't grade it. We won't be able to see it, and so you'll get a 0 on whatever we can't see. And then get a photo of your element in one of its uses. So for example, one of the carbon uses is as coal. So I would go here and I would go ahead and take a look at coal. And there's a picture of coal, right? So I can go ahead and copy that, come back over here. Again, right click and paste, or you can also insert if it's saved to your computer. So you can save it to your computer and then insert it here. All right, so that's slide number 33. We're then going to jump down to slide 37. So what is your element size compared to other elements in its period or row? So remember, we talked about this in class, that you are smaller if you are to the right in your period, which is the row. And the reason for that, because it's going to ask why, is because remember that you have more protons to pull in the same valence shell. Okay, so taking a look at an example here. All right, so carbon, right, is in period number 2 here, right, period number 2, which means that it has 2 shells, right? So every single atom here has 2 shells, which means they're all trying to pull in the same shell. They are all trying to pull in the same valence shell, the second shell, right? So in that case, as we go more and more to the right, remember that we're adding protons, right? Lithium has 3 protons, beryllium has 4, all the way down to fluorine. Fluorine has 9 protons. And so the more and more protons you have in your nucleus, if you're trying to pull in the same valence shell, more protons means you're more attractive, right? Because you have more positives to pull in that negative valence shell because opposites attract, right? So in this case, carbon's actually in the middle of its row, 1, 2, 3, 4. So it's kind of in the middle of its row here. So carbon actually, I would say, is a medium size. So for my example, I would say, right, for my example, I would say medium, and the reason is because it has a medium amount of protons to pull in the same valence shell as other atoms in the same period. Sorry, I should fill that in. As other atoms in the same period. You can absolutely go ahead and copy this right here, this reasoning, but make sure that it's specific for yours. So if yours is small, then you can use this reasoning. If yours is to the left, so if you're more to the left here, like lithium and beryllium here, then you would say yours is large, and you would explain because there you have less protons, right? So medium protons, less protons, more protons, etc., etc. So then down here, what is your element size compared to other elements in its group or column? Again, groups and columns are vertical. So now we're going to go ahead and take a look at the vertical. So let me go ahead and box that for us. So here's carbon in its family here. And what we learned the other day was that in groups, you're actually smaller at the top of your group. So we know, let's go ahead and draw that up here. You're smaller if you are at the top of your group, which is the column. And the reason why is because you have less shells to block the protons in the nucleus from attracting the valence shell, the outermost shell, right? Valence is the outermost. So let's take a look here at this example. So carbon is in period 2, and so it has 2 shells. Silicon is in period 3, it has 3 shells. Germanium has 4 shells. Tin has 5, lead has 6. So as we go down, 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 we're getting more and more shells. And so the more and more shells we have, the less electronegative, the less attractive we become to atoms because you're getting too big. As you get so big, you have a lot of inner shells that are preventing you from reaching new electrons, as well as you just have a lot going on already. So when you are a really big, cumbersome atom, it's hard for you to try to attract new electrons. You're just too big, there's too much going on. So smaller atoms, again at the top and at the right, are going to be more electronegative. Again, that is why fluorine is the most electronegative of the periodic table. So again, the more you go to the right, the more electronegative, and the more you go to the top, the more electronegative. Okay, and also the smaller, right? So we get smaller, smaller, and we get more electronegative. So more electronegative. Okay, so that looks good. So you would explain that there. Again, if you're small, you say, because I have less shells, and explain this exact reasoning. If you're medium, that means you're in the middle of your column, right? Germanium, tin, right? Or if you're large, that means you're at the bottom of your column, right? So that would be like lead and flerovium. Okay, so that looks great. So now, based on your element size, does your element have a higher or lower electronegativity? Now, this one we can kind of do in a couple different ways. Okay, so based on this, if you decided that you were both small and small, then you would have a really high electronegativity, right? Small and small means high electronegativity. If you were both large and large, that would mean a low electronegativity. Again, the bigger you are, the harder it is for you to attract electrons because you're too big, plus you have shielding from innermost shells. If you're somewhere in the middle, mediums, small, medium, large, that one can be harder to determine. But here's the cool thing, you can actually just look this up on ptable.com. So it's good to be able to understand how size is related to electronegativity, but we can also actually look up the data on ptable.com. So jumping over to ptable.com, if we take a look here, we're going to go ahead and actually click down here on the left. Sorry, let me clear this out. On the left where it says electronegativity. So you can see here electronegativity is 2.55, which that there, right, if you compare it to the other electronegativities, electronegativity goes from like these smaller numbers, 0.7, all the way to 4. So carbon is in the middle, right? So carbon has about medium electronegativity, and I can say the exact amounts, right? So it's kind of, I'm going to say right here, right, it has a medium electronegativity, specifically 2.55, which is about halfway between 0.7, which is franciums, and 4.0, which is fluorines. Fluorines. Right? And so that is going to give me a medium electronegativity, right? So, which again makes sense why carbon doesn't really give away or take electrons, it actually shares. So that should help you figure that out. Again, the closer you are to 0.7, the less electronegative you are, and the closer you are to 3.98 fluorine, the more electronegative you are, okay? So that looks great. And then based on this, are you better at gaining or losing electrons? So again, if you have a high electronegativity, then you are better at gaining. Better at gaining because you're more attractive to electrons. That's the definition of electronegativity. If you have a low electronegativity, based on what you decided up here, based on your number that you saw in P table, then you are better at losing electrons because you're less attractive to electrons. All right, and this should make sense because high electronegativity, again, this is all of the ones that are going to be our nonmetals, and these ones, low electronegativity, are going to be the ones that are our metals. Okay, now in my instance, again, for my example, carbon has a medium electronegativity, right? This is my carbon example, do not copy. Okay, for my carbon example, I would end up having a medium electronegativity, so carbon actually is better at sharing electrons. It doesn't really gain or lose, it actually shares. Okay, so that should help you out with that there. All right, finally, slide number 38, taking a look at this one. What's the most interesting thing you learned or reviewed about your element? Specifically, I want you to take a look at your research slide, take a look at your property slides, slide 22, where we learned all about our element. Probably some of these other things aren't as interesting. Most likely the most interesting things are going to be found in your research. So choose one of those things. You do have to choose something, okay? Don't just say IDK. Don't just say nothing was interesting, okay? You have to actually tell me something specific. So be specific. Do not just say IDK. IDK. I don't know. I don't care. Nothing, everything. Okay, don't say those things. You need to be specific. Same thing with what went well and what you can do to improve. Tell me what's the one thing that went well. So maybe that was taking your notes really every single day. That might mean looking up some really good research. That might mean doing the calculations. Tell me what's something that you felt confident with, whether it was in your notes, in your project, whatever was going on in these slides that you felt really confident with, go ahead and talk to me about that. If there's something that you can, what is something that you can do to improve next time? Everybody has a way they can improve. Maybe it's I want to make sure I get things done during class. Maybe it's I want to make sure that I do a little bit of my project slides the day that I learn about them. Right, I want to begin to apply my stuff right away. Maybe it's that you know, I want to get more interesting research, that kind of thing. So there's always something that we can do to improve on future projects. All right, so that's all we need to do. Thank you so much, and I will talk to y'all later.